Good day. Today we're going to be doing question 3 of the November 2024 Physical Sciences. Paper 1. Good. So one thing that made me to like this question was the way it was structured, and it was very fun. Well, 3.1, it says that use equations of motions only to calculate value of each of the following on the graph. So we're going to try and use our equations of motion. So we want to calculate t. So one thing that is happening, you must understand that it's for us to calculate t, these were thrown off at the same height above the ground. So that is our delta y right there. But the times were different because they have to strike the same the ground at the same time. As you read there, ball A is thrown vertically upwards at 12 meters per second from the top of the building. 2 seconds after ball A was thrown upwards, ball B is thrown vertically downwards at 5.4 meters per second at the top of the roof. So I will go and make two equations for A and B. So for A, I'm going to have delta y, which is going to be equal to VR and then delta t plus 1 over 2, and then A delta t squared. So if you can notice, I will call delta t A for A will just be delta t. My delta y will finally be equal to, since it's A, I'm going to also remember to take direction up is going to be positive. So this tells me I'm going to substitute my acceleration as negative. So my VI is going to be 12, and then the delta t is going to be not known, and then plus 1 over 2, the acceleration is going to be negative since acceleration is always acting downwards. So this is going to be delta t squared. And then I finally found my delta y for A. But what about for B? For B, still up is positive, and then you will need to find the delta y also. And delta y is going to be negative 5.4. In this case, let me also plug in the equation of motion VI delta t plus 1 over 2 A delta t squared. And then I have finally the VI is going to be minus 5.4. Why the minus? This is thrown vertically downwards. We took up as positive. Anything going down is supposed to be what? To be negative. All right. They also told us that 2 seconds after ball A was thrown. So the time here is going to be delta TA, what is it? Minus 2, and then all in brackets plus 1 over 2. The acceleration is still going to be negative 9.8. And then our delta t is going to be delta TA. This is supposed A, and then minus 2, and then all squared. That's going to be our delta y. Since they are thrown off the same height, this delta B here is going to be delta A. They will be equal. So from there, I'll be able to solve my time, which is this time here, delta TA. That's the time that we're looking for. It's called T. So instead, I'm going to use the equations. I'll say delta YA is going to be equal to delta YB. They are thrown off the same height. Now, finally, I'm going to have 12, and then T, and this is going to be plus 1 over 2, and then negative 9.8, and then T squared is going to be equal to negative 5.4, and then T minus 2 all squared. This is going to be equivalent to, let me try to increase some space there. So this is going to be T minus 2 plus, and then 1 over 2, and then negative 9.8, and then T minus 2 all squared. So finally, I have such an equation. Simplifying it, I'll have 12t and then minus 4.9 t squared. This is going to be equivalent negative 5.4, and then t minus 2 there was no square here. So this is going to be t minus 2, and then minus 4.9, and then t minus 2, all in brackets. Okay, solving this, I need to solve for t now. It's going to be simple. If I can notice this term here is going to be happening here, I will have to cancel it out later. So I can say negative 5.4 by t is going to give me negative 5.4 t. This one will be plus 8.8, the multiplication of this, and then finally I'll have negative 4.9, and then t squared minus 4t, and then plus 4. This is going to be 12t minus 4.9, and then t squared. Okay, proceeding with this, I will now finally have a t value of how much? How much is going to be my t value? I'll have to negative 5.4 t plus 8.8, then minus 4.9 t squared. This is going to be plus 19.6 t. This is going to be also minus 4. That's going to be minus 19.6 t. Let me just use this. This is going to be plus 19.6 t, then minus 4.9 multiply by 4. That's going to give me minus 19.6 also. So now I have 12t minus 4.9, then t squared. Finally, the negative 4.9t, both left and right, will be cancelled out. And then I will have on the right-hand side 12t, and then plus 5.4 minus 19.6. These are all in terms of t. And then this will finally be what? 8.8 minus what? Minus 19.6. Is that 8.8 there? Let me punch my calculator and check if this value is 8.8. That was 10. It was supposed to be 10.8, isn't it? .4 multiplied by 2, that's going to be a positive 10.8. Yes, that was a plus 10.8. That was a plus 10.8 there. That is also 10.8 there. And then finally, I'm going to have an answer of how much. The answer here will be 8.8. Then I will need to say, what is it? I will need to subtract the values. The like terms 10.8, and then it's going to be 10.8 and negative 19.6. 10.8 minus 19.6 is giving me negative 8.8. And then on the right hand side, I have negative 8.8, and then 12 plus 5.4, and then minus 19.6. This is giving me negative 2.2 t, which is equal to what? Negative 8.8. And then my t now will finally be what? 8.8, a positive value, 2.2, which is going to be 4 seconds. So there it goes. Our time there is 4 seconds, and then we're very much happy about the time. Next one up, I'm trying to now calculate Z. What is Z? 3.1.2. Z is the height of the building, so it means I can use any one of the equations that are deduced above. So I know delta y is going to be what? Vi delta t plus 1 over 2, and then a delta t squared. And then I'm going to use the one for a to calculate that z. And then z will be vi, which is what? For a, that was 12, positive 12, and then time, a was 4 seconds, and then plus 1 over 2, That's going to be plus 1 over 2, and the acceleration is negative 9.8. And then t squared, that's going to be 4 squared. And then finally, z is going to be equal to what? We punch the calculator and get the value. And then we're getting a value of negative 30.4. This is 30.4 downwards, then remember up is still positive here. So this is going to be 30.4 downwards. So we are done with that z, and then now we are going to try and calculate y. What is our value of y? Y, this is 3.1.3. They want y. So the y that they're talking about is the maximum height above the ground. So we still have to find the maximum height for ball A. So one thing that I know, at max height, velocity is equal to 0. Vf equal to 0. That is for ball A. For ball A, the ball A is the one that goes and reaches that maximum height. So I'm going to say Vf squared, Vi squared plus 2A, then delta y, and then it's going to be 0 squared. Vi is going to be 12 squared, and then plus 2. Acceleration is negative 9.8. Up is still positive. Remember, we started with this motion up was positive, and then delta y. Now solving for my delta y, it will be simple. Delta y will be now 144 divided by 2 times 9.8, which is giving me what? A value of 144 divided by 2 times 9.8, which is 19.6, 7.346. This is in meters. So now I'll have a final, what is it, y value, which is equal to the 30.4, and then plus the 7.346, and then the height is going to be what? That y will be now 37 at 30.4 plus 7.346, and that's going to be 37.746. This is in meters, and then we're okay. That's it. Next one up, we're going for 3 point what? This is 3.2. We are sketching the graph of what? On the same side of axis, sketch the velocity time graphs for ball A and ball B. Say velocity time graph, we have such. And then we are going to have, what is it? Velocity, and then this is going to be time. Velocity is in meters per second, and then time is in seconds. So remember, we'll have to go all the way to the other side since there's a negative. Up is positive here. So I will start off now. I know the initial velocity for A. They said that I need to label certain things, the initial velocities of each ball, and then the time at which the ball is thrown, and what is it? The time at which the ball strikes the ground. So I will need to remember that that will be happening at 4 seconds for ball A. So ball A starts at 12 meters per second, positive value, up is positive, and then it goes and reaches a maximum height. And then after reaching a maximum height, it hits the ground after some time of 4 seconds. Remember, this is a straight line graph. So after 4 seconds, it hits, what is it? Ball B, this is going to be A. But then for ball B, we start at 2 seconds. After 2 seconds, we need to be starting. So there it goes. We need to sketch it from the 2 seconds and at an initial velocity of negative 5.4. And then we're going to say this is going to go where down. It's going down and it hits what is it? Hits the ground at 4 seconds. So we can notice that this they'll be hitting the same at the same time. They'll hit the ground at the same time. That's going to be at 4 seconds. That is ball B. And then we are done with that graph. But those are all the things they asked us to show. Because on the same set of axes, sketch the velocity time graph for ball A and ball B while they're in free fall. Label the graphs A and B for ball B, A and B respectively. Clearly indicate the flow in the graph. The initial velocities, we indicated the initial velocities. They are on the y-axis, and then the time at which the ball strikes the ground, we indicated the ball striking the ground. That is 4 seconds. Okay, we are fine. I think that was all for question 3. Yes, if you have a problem, you can ask in the comment section. This is the suggested memo for question 3. If any correction is there, you must put it up. Thank you.